Hello, this is session 1875 VMware Code, Demystifying Container Networking for VMware Tanzu 2022 update. My name is Tuan Nguyen, Senior Technologist, Networking and Advanced Security Business Group. I'm with Rahul Donetis, gonna show you the great demos. And in this session, we're gonna do a live demo, and you can follow that and do a live demo along the line with us as well via the link we provided called VMware Test Drive. Right. Let's look at the presentations and we go with the demo. First, let me introduce the agenda today is the introduction for modern app connectivity and services. We call that the MAS, M-A-C-S. We're going to do the market research. We're going to take you through some solutions, why VMware come up with the VMware MAS solutions, and what are you doing, and what exactly is the solution. And then we see how the mindsets should be changing to the new way for the SLO, SREs, for the DevSecOps persona. How you, most of the people I saw the survey in the room, half of you guys are the cloud architects and half is the infrastructure folks. So let's look at how we can have this solution. The MAS can help you to build the whole journey end to end to adopt with the modern app connectivity and services. And then we introduce you three different major products: the Tanzu Service Mesh, call it TSM, the S1 load balancer NSX, gonna call AVI, and then the container working with VMware Antrea CNI. Let's have a look at the market research. We have 83% or 4 out of 5 people, the workload now running more diversified. This means what? It means can run in multiple environment, could be multiple on-prem and on-prem in the cloud, in hybrid or multiple clouds. That's the nature of the survey we have recently. And the status goals of the multi-cloud 2022 even emphasized that the survey we did end of 2021. Now in 2022, even more people moving to the clouds. And the challenge you guys facing, or we all facing, is the smart migrations. How we manage that across multiple environments. Because you having one on-prem or two on-prem is way easier than some on-prem, some in the cloud. And the consistently policy management and resource management, all of that together. And not only that, you need to make sure you can do migration between those environments. And the new star coming up recently is the cloud native applications. And more people that deploys in the enterprise in the modern app, we do together on three initiatives: the smart migration, the multi-cloud, and the cloud native. Almost 50%. This is from last year, 44%. This year, I believe, 48, 49%. Almost half of folks in the enterprise, they have all trees together deploys. In two phase of that initiative, that's it from our CEO Raghu, we VMware can do for you guys, especially for the secure networking team here, how we adopt and support your application running either private or public clouds together, or could be at the edge. That's how we're gonna come up with the VMware MAS solutions to adopt with a new challenge or the new way you people interacts between functions. Is it dev, development the app, sex with the security in the operation side, transfer from the dev to apps and to ops, which is infrastructure. The whole thing, this is continuous loop. This is not phase 1, phase 2, phase 3. This is a continuous loop. So DevSecOps and DevSecOps along the line. So continually deploy and integrate CI/CD things. How we go and adopt with new models in the customer have facing more and more challenge. They can run in one environment, could be multiple environment, and they see the convert a new way to develop and deploys. They call it a new mindset. The persona mindset change it. So the application now is defined by the SLO, because the application now is sitting there for a segment 1 year like the SLA kind of things. Now we need to define the service level objective. How much latency you want to tolerate it, how much errors you're going to tolerate it, kind of thing like that. So the new way cloud architect developers, they just work as SLO mindset. So the next slide, I'm going to define exactly what SLO means, what the SLI means. And now together you are most likely in the infrastructure side, SRE now, new term, platform operators. You need to know monitors everything in and out and manage your environment. Underneath now, it can be VMware environment, could be in AWS, could be in Azure, could be any kind of clouds, right? And then the application, those are the people we're going to be serving. We need to serve them. And they just look at the SLI. What they do means SLI. They look at latency, how much we're gonna click on that, how much time you need to wait, how much availability, errors, throughput, how fast it can go, how fast the response time, how long it lasts, right? That's the kind of thing. So the SLO is defined by developers. The SLI is exactly what is being consumed by the consumer or application. They're gonna interact with your microservices. It could be VM, could be anything running behind the scene. For them, just the SLI, right? This is a new mindset change. So VMware come up with VMware Mass Modern App Connectivity Services, allow you to satisfy and address those challenges. So we have the full, call it pyramid of products and solutions. First, starting the foundation is NSX. They manage on a VM workload infrastructure, virtual network, they call it. So virtualized infrastructure with vSphere, NSX go along with that. It's still there. And as it create a foundation, we call it network fabric. And on top, we have the load balancer, layer 4, layer 7, on top of the CAS container as a service. Now we come up with Antrea with a CNI plugin to do plumbing networking for container running, could be inside a VM, could be a bare metal. And then we have NSX ALB, Advanced Load Balancer, formerly called AVI, right? It can do a layer 4 load balancing and layer 7. Because of that, it can activate the WAF to protect your north-south or go do east-west protection as well with other features. And can do auto scaling, GSLB, global load balancer, what we're gonna see in the demo later on today in the live environment. And on top of the pyramid, more or less, it's microservices. And Tanzu Service Mesh is right next to the microservices, allow them to connect all of the things together. You can see the end-to-end visibilities, along with CBC, like container security, to do further inspection at the workload security or at the endpoint. In this case, is the container level. Now, look at the whole pyramid. They come up on the left on the infrastructure, could be Tanzu, TKG, Tanzu Kubernetes, Tanzu operations. Those are the things really on the left. On the right, on the networking security solutions, we're forming the whole flow. Let's look at a simple flow. And here, how you start with the Tanzu Service Mesh, and we scale the application to the cloud, and then we need GSLB, Global Load Balancer, to load span between them, to turn on the WAP to protect your north-south. And you're going to apply on the way to Antrea and NSX to help you scale that to the policy of each cluster you have. So not changing what you do, but just add a lot of more value into that. So that's the whole key solution of VMware Mass Modern App Connectivity Services. Let's deep dive into the first topic with the Tanzu Service Mesh. What is it? So this allows you, see, remember at the beginning I'm talking about the two challenges, right? The app resiliency, now not running one location, across multiple locations, running multiple clouds. So the all other challenge you're going to be asking to certify the SLO, service level objective. How you scale it, how you roll it out to multiple environment, could be same environment, but multiple VPC, could be multiple data centers. And you use GSLB, you use multi-cloud connectivity services. That's here, and we have like 3 environments, one running in cloud 1, called it cloud 2 and cloud 3, and we use GSLB to tie together. And on top we have GNS, the new concept we're going to talk later on during the talk about the global namespace. This is a logical abstract VMware Tanzu Service Mesh come up with to allow you expand and abstract the application to another layers. So who don't know networking, so you have layer 4 on the way to layer 7. Now it's called a layer 8. You want to call it on top of that. The layer 8, you want to push the policy and abstract everything, and then bring it to layer 7, which is the application level to run. Okay, let's look at the next topic. So zoom in the app resiliency. You have an app. Now in this case, we have e-commerce app. We run in one location. Now you scale to multiple locations. You have exposed all the APIs. Now you define the SLO to satisfy the user expectations. Right? That's exactly meet the SLO with the application SLA. And now you move to the cloud. So this application now is moved to the cloud. Multiple challenges you'll be facing. You'll be asking how to do service discovery, how to do elastic scaling, how to do cloud bursting if something wrong in one location and when bursting traffic to another locations. How you easily satisfy the DevSecOps lifecycle. So they can have half of like application running on-prem, half running in the cloud. Exactly what you see in the next demo. Right? That's all the challenge we're facing. So the Mass completely address those challenges. So with the 3 pillar products, we call it. First is Tanzu Service Mesh, do the all SLO, helping you to easily via a single click with the GUI guidance. We can go and create the rules and policies, group all the services, abstract it, and do the intelligence of the scaling whatever needed, and expose you an API to detect the whole API security. For those who want to deep dive into API security, is the next session, right after this session, back to back. You see how we're gonna do that. But this session more focused in the foundation of networking for the modern app. This one, Tanzu Service Mesh. Second one is the load balancers. You can do auto scaling, load balancing, help monitoring, all the full benefit of RV analytics behind the scene. Last but not least, and then you come down all the way to layer 4. That's allow you the VMware Antrea, the CNI container networking interface, allow you to create a central place policy with NSX, integrate with Antrea, and do the network troubleshooting for port-to-port communication, port-to-service or service-to-service communication. And then you do tagging grouping on container. Now, because of NSX of nature of that, you can integrate with VM and bare metal workload together with Antrea, with the container. Together, we create a full visibility. No one else on the market to do all of that in the one single bundle. And this single bundle, the mass bundle, allow you to do all kind of service from layer 4 all the way to layer 7 or layer 18 when you call it. So let's look at the first demo. Zoom in Tanzu Service Mesh. The nature of that in every services, the microservices, here they create the Acme namespace with Antrea running underneath, allow you to create all the services, right? And then you create a sidecar running on top. So every sidecar allow you to communicate with the services. And here we have 4 S4 services, there are 4 sidecar, very slight proxy. You talk with Tanzu Service Mesh global controller. And on top, we define the global namespace. So the global namespace can expand multiple clusters. In this case, we have only one. Just do this one, and we expand for the next scenario. Let's look at the global namespace. What is the role for? The global namespace can do a lot of things. So 4 different things is discovery, DNS, identity, policy, observabilities. Those are the key features for Tanzu Service Mesh, what we see in the first demo. And now, before I go to the demo, let's zoom in define the scope for this demo. We see the whole DNS. Right, how we see that the traffic flowing around, and we can do all of the security features, automation, visibilities. We abstract completely everything from the infrastructure at the bottom, and then we start pumping a lot of traffic into the platform. At some point, you're going to generate some latency, error rate, and they're going to violate the error budget, and then they trigger some SLO violations, and then ultimately the system going to auto scale on demand based on the rule you defined, and then after that, traffic gonna get back to normal. But not only that, we go and also see if any attack, the more traffic you come in, the more chance you have more attack coming, and then you're gonna be detected by the API discovery and we detect and block, create the rules to allow and block traffic. This is the second part is in the second session you see in the next hour. But let's look at the first scenarios. Before I go to the demo, let's give the definition. For those who don't know the SLI, SLO, SLA, the thing here, we work a lot on the SLO mindset, right? The SLO is rely on multiple SLI. So SLI is the service level indicator. That's the real thing the customer gonna receive and see and perceive it. So well-defined measure of good latency, packet loss, or throughput, any delay, anything that SLI means. The SLO is the top line target for good interaction with this service. So we define an SLO. In this SLO, we have multiple SLIs. That's the key. This is a kind of key API we're gonna call it, compare with the old school. Then, example, what does it mean exactly SLI? SLI, look at the cat here. You define the SLI written in English, right? And then technical discussion, blah, blah. But example, when the site is loaded, how much time I see is the portal loaded, latency, I can see, let's say 10 seconds, 5 seconds. Those are latency. This is the SLI for me as a users, right? And then example for the SLA will be availability 99.95%. The SLO should be likely 99.95 or higher. That's maybe 96, 95, 96 or 99, 99. And then what exactly the key metrics, right? Availability is the key, right? So the SLO at the end of the day, they define how much time the service be available for you. So then based on that, you define the error budget, right? This is 90% of the time available. That means 10% of the time you don't satisfy that. You got an error budget. So the error budget is about per month. We calculate per every 28 days, with almost 2.8 days per downtime to get an SLO 90%. So that means the 100 subtract the SLO is the error budget. So that's the key thing, right? The error budget, the less error budget you have, the better service you're gonna get. right? Now, the goal in the SLI metrics, what you tell you some things. The SLO threshold will tell you the user asset or good, love or don't like it, whatever. Error versus exactly tell you how much more user will take, right? So that's the, if error budget is, let's say in this case, 90%, this means availability is only 90%. 10% of the time people don't see the good service. Okay, let's go with the demo. You see exactly what I'm saying. Before I go that, the sick mindset, I want to make sure you get it. So the thing like SLE and like product manager, look at the persona, who your DevOps, cloud architects, infrastructure, or user. Look together. Look at the whole journey DevSecOps along the line. This is a continuous integration and continuous delivery. And track the success by the SLO you define, and go and make the adjustment, pick and assign your right SLO, and then monitor updates constantly, whatever things needed, and look at the error budget. Monitor that, trigger the process, auto scaling, alert, things like that. So maybe I talk a little bit too much, but to recap, the 3 things you need to know. The SLI, SLA is exactly what you promised. It's not the real tracking for the modern app anymore. We rely a lot on SLO. We define the goal. This shopping service, this database service, how much is the goal? I want to achieve 99% or 95, whatever percentage. The SLI, how to get to 95%? I need to have X amount of latency, X amount of packet loss, things like that. Based on that, we define together, we create a rule set. Auto scalings go along with SLO and SLI. So we want to remind, this is how you need to remind the goal and how did we do. SLO is the goal we want to achieve. SLI is how did we do that? By which KPI we want to go for that.
Thank you, Tuan. Let's look at the Tanzu Service Mesh demo. This slide shows us the demo flow, which we're going to show in the lab. So let's consider a scenario where they have deployed a microservice-based e-commerce application on the Kubernetes cluster. The cluster has been onboarded to Tanzu Service Mesh, and the application has been configured with a global namespace. When the Acme, as the traffic comes to the application, right, the application will be auto scaled with respect to the traffic. As the traffic keeps on increasing, the SLO can be healthy only until on-prem resources get exhausted. In this demo, we will observe the SLO and application performance metrics for over a period of time in Tanzu Service Mesh. Let's get into the demo. This is the Acme Shopping global namespace, which has been configured. We have onboarded the Kubernetes cluster. All the services make up the Acme Fitness application. Let's switch back to the SLO view. We have configured an actionable SLO for the shopping service with the JNS scope as our Acme Shopping. So this describes the high-level objective for acceptable operation and health of shopping service over a period of time. So our P50 and P90 latencies has been configured as a service level indicators, which are the conditions for our target SLO. That means 90% of the requests responses must be equal or faster than the P90 latency value. And the service should be healthy for 90% of the time as our SLO, service level objective. The estimated monthly error budget for the shopping service is 3 days. So we have enabled a service auto scaling here. Let's look at the auto scaling policies. Again, the auto scaling has been enabled for the shopping service with the performance mode configured as efficient, which will allow to scale up and scale down the service as per the auto scaling metric mentioned here. We have configured our auto scaling metric as the P90 latency for scaling up and scaling down condition. This condition can be configured with in regards to CPU and memory metrics, CPU usage percentage and memory usage percentage as well. This policy has been activated. Let's switch to the application view and see the application status here. So the application has been deployed on on-prem SDDC site and application access seems to be normal. Let's switch back to the TSM console here and explore the shopping SLO status over a period of time. So we are looking at the historical data of the shopping service. As we can see, the error budget of the shopping service as being consumed and the respective SLO values are being higher than the configured threshold values, which resulted in the SLO being depleted continuously for a period of time. These are the metrics of the shopping service over a period of month. Now let's look at the status of the application metrics currently. So as we can see, the shopping service has been healthy and the performance metrics are normal. The instance auto scaling shows the designed instant count as 2. That means it's a minimum count for our shopping service. And all the P50, P90, and P99 latency are not reporting any higher thresholds, and the errors of the shopping service are normal. At this point, let's increase the traffic to our application, and we'll monitor how the SLO and the performance metrics are impacted. So we have generated a traffic gen for our application. As we can see in the shopping SLO, there are multiple violations detected within the SLO. And the error budget being depleted completely, and the error budget is going in a negative value. Let's see the reason for this. As we can see, the P90 latency is very much higher value than the configured SLIs. And let's see the instance auto scaling policy. As the traffic increased to the application service, the auto scaling policy has been triggered in and scaled the shopping service to the maximum instance count. As our error budget is already burned out and the violation has been the negative values, it is evident that the shopping service has been running with the fullest capacity here, and the latency values are not reducing, which affecting the SLI, in turn causing the SLO to be violated. As the traffic keeps on increasing to the service, the SLO cannot be on a healthy state because the on-prem resources gets exhausted. Let's see the application performance during this period. As we can see, the application performance has been degraded and users might be facing the slowness issue. To conclude this demo, TSM Global Namespace provides consistent traffic routing, connectivity, and resiliency to the Kubernetes clusters. We can redefine our SLO and auto scaling metrics to meet our current application architecture. And to provide the users with an optimal experience for the application, let's now scale the Acme shopping application to the multi-cloud environment with the help of Tanzu Service Mesh and Advanced Load Balancer.
Thanks, Rahul, for the nice demo. Let's look at the second step, right? After you saw Tanzu Service Mesh, now the application now need to scale from one cloud, which is on-prem with TKG. Now we're gonna expand to the cloud. So how we connect them together? NSX ALB Advanced Load Balancers, which we formerly call AVI, is the right solution. It can run on the way from layer 4 load balancing, hook up with the DNS GSLB, connect to Tanzu Service Mesh. So basically you can create a service from Tanzu Service Mesh, push it onto NSX ALB, integrated inside TSM, and fully scale to multiple clouds, and helping to scale the app and load balancing the apps. And next section after that, you can turn on WAF for the security features at the front end for north-south traffic coming through that. But here let's focus for the networking part. And to get back to why we come up with an NSX ALB RV load balancers, this is the nature of the Kubernetes thing, right? We need to deploy Kubernetes cluster, and in front of that, you need to export to AWS and have the load balancer and call it network load balancer NLB L4, or in the on-prem we do F5, and we do the WAF with the Imperial or different vendors, IPAM, Infoblox, whatever. Now together, RV can do all of that. NSX ALB or RV, they can do all of that, included the GSLB, all single solutions, and helping to scale, easy to manage, easy to operate it. So in this demo, we're gonna focus on GSLB and DNS. The next demo in next hour, you stay here, you're gonna see more about the WAF and other security features. So to recap, it's easy to use, fully integrated together in the mass bundle, fully embedded and integrated into TSM Tanzu Service Mesh, and turn on in one click on the features you see it. And here we focus more on the networking side, where we're gonna show you how the GSLB Global Service Load Balancer and scale across multiple clouds. Could be on-prem, could be on AWS or Azure. So the way it works in the first cluster, we have TSM. Now expand to the second cluster from on-prem to the cloud. And from two cluster, TSM gonna hook up via AVI controllers and create the connectivity to the DNS and GNS, GSLB, allow you to, let's say, create a new FQDN acmefitnet.vmwaredemo.com. So they're gonna tie into AVI DNS, and from GSLB they can load balance between the two L4, which is also AVI. So one side fit on, okay, one single solution can do load balancers, GSLB, DNS, this is AVI, and that's fully integrated into your cluster. So it really is an CRD inside your cluster. Here you have two clusters, one on-prem, one on the cloud. See how it looks? Now, before I go that, let's Rahul gonna walk you through the lab topology. So this is what we've been built for this demo, and Rahul gonna walk you through that. Go ahead, Rahul.
Let's look at demo 2. In this demo, we'll see the Tanzu Service Mesh and AVI GSLB to scale the application to the multi-cloud. In the previous demo, we have seen the application has been deployed on-prem. Let's scale the application to multi-cloud. So we'll be using TSM and GSLB to load balance the application running across on-prem and AWS cloud. It helps the users to provide optimal user experience for users distributed geographically. And application resiliency is ensured to loss of data center. Let's switch back to AVI console and look at the global namespace configuration. This AVI GSLB is configured with GSLB. So to provide GSLB services, to make a note here, the VMware-demo.com is a dedicated subdomain to the GSLB. What that means is this AVI controller should be able to resolve to that subdomains. As we can look at the GSLB services, there are no GSLB services configured currently, and the GSLB services are empty right now. Let's switch to TSM console to do an AVI integration. So TSM allows us to do an integration with AVI and AWS for providing DNS service. Once we integrate the AVI with Tanzu, let's configure DNS and domains. We need to configure this DNS and domains, and it will be attached to the global namespace what we configure now. So let's switch back to the global namespace configuration. What we'll do is we will add the AWS application cluster as to this global namespace. As this is a rule-based engine, once we add the Acme app namespace, the application services will be automatically detected, and we'll configure a public URL for the shopping service. The application will be available at the public URL what we configure here. As we can see, the VMware-demo.com, a dedicated subdomain to AVI GSLB, has been configured with the public URL. The GSLB and resiliency state is set to the round robin. Let's finish this configuration and head back to GSLB console to see the status. As we can see, the GSLB is been automatically created when we configure the public URL for the shopping service. This is the representation of the global application. These are the GSLB pool member collection. What had happened is the automatic health monitors are also created, which are responsible to monitor the status of the pool members. So we can see here the load balancing algorithm is set to round robin, and the pool members are from AWS and on-prem sites. At this point in time, let's access the application with the public URL and see the status. As we can see, the application is accessible from the AWS public cloud side. As I refresh it, you can see the application is accessible from both on-prem and the AWS side. So as we configure the application load balancing as a round robin, it is served as the application is served from the two different sides. Let's bring down the application down in the on-prem side to see the application availability. So once the application is down on the on-prem, we will review the status of our GSLB service. So as we can see, the shopping deployment has been deleted from the on-prem site. Let's head back to Avi, and we can see the GSLB pool members are marked as down. We have a follower failure here, and GSLB config is synced with currently up site. The DNS service marks this global GSLB members are down state. Let's check the status of our application. So as we can see, the application still be accessible from the cloud site. Yeah, so let's bring back the application service online on the on-prem site. Yeah, the application has been running from the running on the on-prem site again. Let's head back to the GSLB console and see the GSL. As we see, the GSLB services are marked up once the application became online. So it is to conclude this demo, the TSM and RV GSLB facilitates the development and management of microservice-based applications across the sites in any cloud. The services offered are beyond application load balancing, like application resiliency, predictive auto-scaling, and service health monitoring. Thank you.
Thanks, Rahul, for the second demo. After the second demo, now you see TSM integrate with the NSX ALB, so load balancer. And from that, we're gonna add more services. Now we add Antrea into that. So what Antrea doing? We see in the next demo, which is the last demo for today. So you can see the CNI plugin allow you to go all the way to layer 4 to create the rules, grouping on the paths together or services together, and create the rules and automate it and encapsulate it and integrate with NSX as the foundations for the network fabric and see how it looks. Before I go to the demo, let's just walk through the couple steps. This is from last year presentation, but it's a recap for folks didn't see Antrea. You can see exactly what Antrea doing, why we need the Antrea, how Antrea fit into the full picture along with TSM, AOB, and NSX together. So let's deep dive into Antrea. Antrea basically is running the Kubernetes networking, right? So there are two parts. One part is in the picture. You have one master and a couple master, three master and three worker nodes, right? And here the blue is the Kubernetes component. On the top you have a controller with API server, controller managers, on schedulers, and on the worker node. Those are the blue component. Antrea coming and do the green boxes, and they have controller running Antrea controller on the top. Is offload some workload from Kubernetes master node, so allow to offload some API to Antrea controller and much more performance in terms of controller plan. In terms of performance, we run a couple reports for performance. You see it after the call here. I give you some link, you can check it out. And then here on the data plan, we fully use OVS and fully owned by VMware, but this is the CNCF project we donated to CNCF. Antrea is the default blocking for some vendor as well, so you can deploy on AWS, EKS, or Azure AKS, or other environment, right? And here the CNI plugin allow you connect them together. Let's say you have a couple paths deploying in different nodes and connect them together. We represent as a service, right? Service represent the path, and for service one want to communicate with service 2 or service 3. Basically, you're gonna go through the network policy. This is how Antrea coming and shine up that. So allow you to define the policies along with NSX, even automate the whole thing and scale much more faster. And then you just hook up one component with the plugin from Antrea to NSX. That's it. And then we can have a network connectivities, so pod can communicate with other pods, right? Pod to service, and we with our NAT or with the network policies allow or block traffic. That is the whole level of Kubernetes networking with Antrea, or Auto CNI does almost the same thing, right? So we do much better in terms of performance. We scale much better. We can connect to NSX. We can see that we can tie into NSX. We not only container, now we tie with virtual machine, bare metal, all in one single place with NSX. That's the whole power of Antrea. And we make a lot of improvement on the control plane and also on data plane and much more performant than other solutions. So we have some report to do to show you to how we are better than other solutions as well. And then the Antrea now integrate with NSX, right? So that's the beauty of Antrea now can deploy is on different environments. So we have VMware Tanzu TKG on-prem, we have Azure, AKS, and we have EKS running on AWS or even eventually OpenShift, whatever. And then NSX is plumbing all of that. So underneath you have Antrea running every single cluster. You see Antrea running on-prem, on Azure, on AWS. And then we can scale it from the management side, connect to NSX. From there, NSX it becomes like a single panel class, allow you to orchestrate Antrea run in different environment and different clouds, and also tie with all the type of workload, VM, container, bare metal, all together in one single place. And that's the central policy management, the full visibility and troubleshooting, everything inside NSX GUI as well. And look at the demo, you see it. So this is the demo. So Rahul gonna walk you through how Antrea working. So how it connect to Kubernetes. From that, that's the green part is the Antrea plugin. So directly connect and built inside your container. And then from there, you sit in on the top, and NSX manager allow you to orchestrate that.
Let's look at demo 3. In this demo, we will demonstrate to manage network policies across multiple Kubernetes clusters. And NSXT also provides central policy management, visibility, network troubleshooting for this multi-cloud Kubernetes clusters. We have 2 K8s clusters onboarded and are running with Antrea CNI and are registered with the NSXT. Let's look at the inventory overview, which has a container section separately, which shows us the containers information here. We'll get into the container section and the cluster overview. These are the clusters registered with the NSXT console. We can see a much more detailed information about the clusters here, the number of pods and namespaces and cluster network policies which are running. Let's switch back to the namespaces view. These namespaces are dedicated view of each namespace and the number of services running on each namespace. The group workflow allows us to create groups of containers. It's a straightforward workflow. Let's edit one of the shopping group and define the criteria. We have to make sure to select the Antrea group while adding the Antrea related, Kubernetes containers. We can select the criteria either through namespace, pod, or the service. Select the pod and define your definition to add the member here. Once we have respective groups, we can apply the security distributed firewall policies to the groups. As we have defined our Acme shopping application service rules here, the entire application rules has been populated and are applied to 2 clusters. So the rules will be consistently applied across all the clusters. The changes made to the rules are also applied to the 2 clusters. At this point of time, let's look at our application access. As we can see, the application access is being normal and all the services are running. Consider a scenario where a random change of the DFW rules broke our application access. So there's a change made on the DFW rule which is not intended, but it had break our backend services connectivity to the front end. As we can see, we can only look at the empty welcome page and nothing has been populated. To troubleshoot this issue, let's switch to the NSXT traffic analysis tool, which is great to look at the policies and the troubleshooting techniques. We'll check the cluster 1 on the traffic type being the TCP, and I happen to know the source port and the destination port for the service, and the source pod will be shopping applied to the cart. So let's see the traffic flow between these two pods. So it is evident that the network traffic between these two pods are dropped by the cluster network policy, and we can see the policy ID has been here. So as we know that one of the network policy is blocking the traffic, let's switch back to the security policy and allow the rule from drop to allow. Let me publish it. Once I publish this rule, the application access is back to the normal. To conclude the demo, Antrea with NSXT provides us central policy management, visibility, and network troubleshooting across multi-cloud and multi-cluster Kubernetes environment.
Okay, and that's the third demo. And thanks, Rahul. And last but not least, recap the whole pyramid you see from the beginning from Tanzu Service Mesh all the way to NSX ALB, load balancer, to Antrea CNI, connect to NSX. That's the whole pyramid. This is on the right side for network and security. On the left side, you see all the Tanzu vSphere, how it tied together in one single picture. And the pyramid should go all the way up. This is the top one, is the microservices. When you run microservices, you need networking and security. And this talk, I'm not talking much about security, which is second hour or second talk. Right after this one, we'll talk more how the same bundle, you can also do a lot of security end to end as well. This is more focused on networking and connectivities. I will scale it up. So to recap, right? So you see the whole picture. On the left is everything running on-prem, right? You can run in vSphere. You run with the guest cluster with Antrea deploy as a CNI, or the supervisor cluster where we have backing. We have NSX, NCP, connect to that, and you have load balancer on every single cluster. And then on top, we see the first demo that we show the TSM is a sidecar which is running on data plan, is a TSM DB, and the controller running every single cluster, and the global controller on the top, which you see in the nice good Rahul just showed in the demo one. And this is one controller. Second one, you saw the NSX ALB, the GSLB, global load balancers, and across multiple clouds. And then the third one, you see Antrea now running on different environment, could be on the left when on-prem, or could be on the right in EKS, which you saw in the demo. And the fully multi-cloud ready solution is a mass bundle from VMware. We are uniquely positioned on the market to do all of that. In this demo, I don't talk about global manager to do all the workloads for virtual machine or bare metal. But here we focus on the purple and the green, the dark or the light blue that allow you to do the end-to-end for modern app scale architectures, fully integrated into one single portfolio. And the next hour we see all we do intrinsic security, API security is the new endpoint. Very interesting to stay and see the next hour what we're doing, right? To recap, right, the three key takeaways from that. First, Tanzu Service Mesh is the enterprise class services from the mesh standpoint, extend the service mesh capabilities, and fully end-to-end visibilities, discovery, connectivity, control, security, observabilities. All kinds of features you have all in one single solution and encapsulate that with the abstraction we have in the global namespace. I'm not talking about more API in the next hour. It is more powerful to leverage the global namespace GNS across multiple clouds, allow you to connect them together. And from there, you can do connectivities, auto scaling, SLO defined like we saw in the first demo, and the API security is a new cool thing we do in the next session. And then along with that, when we scale the app, we're gonna go to multiple clouds. Load balancer AVI is the key to do it. So it's not only hooking up all the cluster together, but also allow you to turn on the services, right? GSLB, DNS, WAF, all integrated into Tanzu Service Mesh. It's the second demo you saw. And the third one, together with Antrea, is the layer 4. And we play the game from all the way from layer 4 to layer 7, from the compute, storage, and networking, along with vSphere, vSAN, and other products we are announcing today. Right? We see vSphere Plus, vSAN Plus, and NSX plus Tanzu Service Mesh plus RV. This full powerful tool set you have on in single bundle when called mass modern app connectivity and services. And thanks for watching this presentation. Let's see some material you can look at from different colleagues, different teams, so from container networking security, from the Antrea, how we connect Antrea with NSX, with OpenShift and all of that. And the deep dive more into Antrea, more modern apps session, the ton of YouTube that I did with the team. I encourage you to look at the hands-on lab and all the materials. We have the live lab, we have here the booth, we have a couple of solutions for secure multi-cloud, secure modern app, and API at scale, connect on together. This is one of the thing you saw today in the connect, scale, and operate modern apps with Tanzu Service Mesh, RV, and Antrea. And check out some other session, keynotes, and learn more about NSX security. I encourage you to go to the hands-on lab zone where we have expert there can walk you through some hands-on lab. We have a couple labs for test drive. You can go and play by yourself, and you can go home learn a lot of nsx.techzone.vmware. And that's it, test drive. You can go and sign up with your email. You can be able to do exactly the lab, and the 3 labs that Rahul and me is showing today, you can do by your own and hands-on that. Play around with that. Encourage you play with that. That's all a unique position VMware can offer compared with all the competitors on the market. That's very powerful end-to-end solution. So please take a survey and give me feedback. Thank you so much.